the installation is incorrect. Using the white wire of the 4-wire cable as the power feed is incorrect. White wires are typically used as neutral conductors, not hot power conductors. Using the black wire of the 2-wire cable as a switch leg is also incorrect. Black wires are typically used as hot power conductors, not switch legs. Using a 4-wire and a 2-wire cable to terminate 4 single-pole switches is acceptable. However, the wiring should be as follows. Firstly, the 4-wire cable white wire is a neutral conductor, and it should be connected to the neutral bus bar in the splice box. Secondly, the 4-wire cable black wire is a hot conductor, and it should be connected to the line side of the switches. Thirdly, the 4-wire cable red wire is switch leg 1, and it should be connected to the load side of switch 1. Fourthly, the 4-wire cable blue wire is switch leg 2, and it should be connected to the load side of switch 2. Fifthly, the 2-wire cable black wire is switch leg 3, and it should be connected to the load side of switch 3. Sixthly, the 2-wire cable white wire is switch leg 4, and it should be connected to the load side of switch 4. All wires should be terminated properly using appropriate connectors. The splice box should be properly sized and accessible for future maintenance. The use of white wire as a hot conductor poses a safety hazard, as it can lead to electrical shocks or fires. The incorrect wiring of the switch legs can result in the switches not functioning properly or creating shorts. It is important to understand the color codes used in electrical wiring. Conventionally, black and red wires are used for hot or live conductors, white wires are used for neutral conductors, and green or bare copper wires are used for grounding conductors. In the described scenario, the incorrect use of the white wire as a hot conductor violates this convention and creates a potential safety hazard. Firstly, the use of white wires for hot conductors can confuse anyone working on the electrical system in the future. If someone assumes that a white wire is always neutral, they might accidentally touch it while it is energized, leading to a shock. Secondly, this can also lead to misidentification of circuits, making troubleshooting and maintenance more difficult. The National Electrical Code, or NEC, addresses the identification of conductors in Article 200.6. This section specifies requirements for identifying grounded conductors, which are typically white or grey in color. Although the NEC allows for re-identification of conductors under certain conditions, such as marking the ends of a white wire with colored tape to indicate its use as a hot conductor, this is generally discouraged and should only be done when necessary and in compliance with the code. The NEC also addresses wiring methods and materials in Chapter 3, which provides detailed requirements for selecting and installing conductors and cables. It's crucial to follow these requirements to ensure that the electrical system is safe and compliant. In the described installation, the misapplication of the black wire as a switch leg also presents a potential issue. Switch legs are the wires that carry power from the switch to the light fixture or other device being controlled. While it is permissible to use different colored wires for switch legs, using black wire for this purpose can be confusing because black wire is typically associated with hot conductors. Again, this could lead to misidentification of circuits and potential safety hazards. When installing single-pole switches, the following wiring practices should be observed. Firstly, connect the hot conductor, usually black, to the line side of the switch. This is the terminal that provides power to the switch. Secondly, connect the switch leg, which can be any color other than white, grey, or green, to the load side of the switch. This is the terminal that sends power to the light fixture or other device when the switch is turned on. Thirdly, connect the neutral conductor, white wire, to the neutral terminal in the outlet box or splice box. Fourthly, connect the grounding conductor, green or bare copper wire, to the grounding terminal in the outlet box or splice box. The practice of using a 4-wire cable and a 2-wire cable to wire multiple single-pole switches is generally acceptable, provided that the wiring is done correctly and in accordance with the NEC. However, it is important to ensure that the cables are properly sized for the intended load and that all connections are made securely and with appropriate connectors. The NEC provides guidelines for conductor ampacity and overcurrent protection in Article 310.15, which specifies the allowable ampacities of insulated conductors based on factors such as conductor size, insulation type, and ambient temperature. It is essential to select conductors that are appropriately sized for the circuit to prevent overheating and potential fire hazards. In addition, the NEC requires that all electrical connections be made with approved connectors that are suitable for the conductors being used. This helps ensure that the connections are secure and reliable, reducing the risk of loose connections and potential arcing. The size and accessibility of the splice box are also important considerations. The splice box should be large enough to accommodate all of the conductors, splices, and connectors without overcrowding. This helps prevent damage to the conductors and ensures that the connections can be easily inspected and maintained. The NEC provides guidelines for box fill in Article 314.16, which specifies the maximum number of conductors, devices, and fittings that can be installed in a box of a given size. The splice box should also be readily accessible for future maintenance and repairs. This means that it should not be buried behind walls or ceilings, and it should be located in a place where it can be easily reached and inspected. In addition to the safety hazards associated with incorrect wiring, there are also potential legal and financial consequences to consider. If the electrical installation is not up to code, it could result in fines, penalties, or even the need to redo the entire installation. This can be costly and time-consuming, and it can also delay the completion of the project. Furthermore, if someone is injured as a result of the incorrect wiring, the property owner or contractor could be held liable for damages. This could result in costly lawsuits and settlements, and it could also damage their reputation. Therefore, it is essential to ensure that all electrical work is performed by qualified professionals who are familiar with the NEC and local electrical codes. These professionals will be able to properly size conductors, make secure connections, and ensure that the installation is safe and compliant. In summary, the described electrical installation is incorrect due to the misapplication of wire colors and potential safety hazards. It is crucial to follow proper wiring practices and adhere to the NEC to ensure the safety and reliability of the electrical system. If you are unsure about any aspect of electrical wiring, it is always best to consult with a qualified electrician to avoid potential problems. When dealing with electrical installations, it's critical to prioritize safety and follow established codes and standards. The NEC serves as a comprehensive guide for electrical installations, providing detailed requirements for wiring methods, materials, and equipment. Adhering to the NEC helps minimize the risk of electrical shocks, fires, and other hazards. Firstly, the use of appropriate wiring methods is crucial for ensuring the safety and reliability of the electrical system. This includes selecting the right type of cable or conduit for the application, as well as properly supporting and securing the wiring. Secondly, using the correct materials is also important. This includes selecting conductors that are appropriately sized for the intended load, as well as using connectors and fittings that are approved for the type of conductors being used. Thirdly, proper grounding is essential for protecting against electrical shocks. This involves connecting all metal parts of the electrical system, such as enclosures and equipment, to a grounding electrode, which provides a path for fault current to flow back to the source. Fourthly, overcurrent protection is necessary to prevent damage to the electrical system in the event of a short circuit or overload. This is typically achieved by using circuit breakers or fuses, which are designed to trip or blow when the current exceeds a certain level. Fifthly, proper labeling and identification of circuits and components is important for facilitating maintenance and troubleshooting. This includes labeling circuit breakers and switches, as well as identifying the purpose of each conductor in a cable or conduit. Sixthly, regular inspections and maintenance are necessary to ensure that the electrical system is in good condition and that all components are functioning properly. This includes checking for loose connections, damaged wiring, and other potential problems. Seventhly, any electrical work should be performed by qualified professionals who are familiar with the NEC and local electrical codes. These professionals will be able to properly size conductors, make secure connections, and ensure that the installation is safe and compliant. Eighthly, it's important to stay informed about changes to the NEC and other relevant codes and standards. This will help ensure that your electrical installations are always up to date and in compliance with the latest requirements. Ninthly, when working on electrical equipment, it's essential to follow lockout-tagout procedures to prevent accidental energization. This involves disconnecting the power source and placing a lock and tag on the disconnect switch to indicate that the equipment is being worked on. 10thly, always use appropriate personal protective equipment, or PPE, when working on electrical equipment. This includes wearing safety glasses, gloves, and other protective gear to prevent injury. In addition to the specific wiring issues discussed earlier, there are several other general considerations to keep in mind when working with electrical systems. Firstly, always to energize the circuit before working on it. This is the most important safety precaution that you can take to prevent electrical shock. Secondly, use a voltage tester to verify that the circuit is de-energized before touching any wires or components. This will help ensure that there is no residual voltage present. Thirdly, never work on electrical equipment while standing in water or on a wet surface. This can increase the risk of electric shock. Fourthly, be aware of the potential hazards associated with working near overhead power lines. Maintain a safe distance from these lines to avoid contact. Fifthly, use caution when working with power tools. Make sure that the tools are properly grounded and that you are wearing appropriate PPE. Sixthly, never overload electrical circuits. This can cause the wires to overheat and potentially start a fire. Seventhly, if you are unsure about any aspect of electrical wiring, consult with a qualified electrician. They will be able to provide guidance and assistance to ensure that the work is done safely and correctly. Eighthly, follow all local electrical codes and regulations. These codes are designed to protect people and property from electrical hazards. Ninthly, keep electrical panels and equipment clear of obstructions. This will allow for easy access in case of an emergency. Tenthly, regularly inspect electrical cords and plugs for damage. Replace any cords or plugs that are frayed or damaged. Always remember that electricity can be dangerous. By following proper safety precautions and adhering to established codes and standards, you can minimize the risk of electrical shocks, fires, and other hazards.